Okay, so as I was saying, I clicked on the last iteration, I clicked apply, I clicked new, then I leave it as 10 frames. That's really up to you, but I'm going to leave it as 10 frames. Now the next thing I'm going to do is click down here for more information or more options, and here you can save the movie. That's what I chose to do, and here you choose the location where you want to save your movie. And what I'm going to show you right now is that I already did two of these. See, I have two different cases. One is with 600 and one with 1000. And so basically you choose where you want to put it. You click save. I'm going to click cancel because I don't really want to save this because I already did this animation. Now also you can do loop, which I think when I did my 1000 frames I selected a loop of 2 just so that like you could see the video loop twice. And that's pretty much it. Now you press now after you've chosen where it's going to be, you can choose a video type. Now to start creating the animation, you click play. I'm not going to click play, but you have to click play. When you click play, you'll see over here a load bar will appear that's going to be basically showing you the progress of the animation. And right here, this counter will go back to 1, and it'll count up to 1002 as it's completing the animation. And for me, that is the main choice why I chose keyframe animation versus quick animation, because with quick animation you don't see the progress. You don't see the progress. So there you go. Now I'm going to close all of these because, as I said, I already did this. Oh, another thing that I should say: whatever you see in this window is going to be what you see in the animation. So if you wanted, for instance, this view, then you've got to make sure that you select that view, put your contour in the orientation that you want it to be, select the right I guess gradients, right? What do they call these? Legend. Okay. Select the right legend and make sure that that's set up before you go ahead and click on play and create your animation, because that's what's going to be in your video, is basically whatever is in this window. Okay, so you got that. Let's go ahead and get out of this window. And as you saw, when I started the tutorial, I had something like this. I had another results box over here because I had done 2 cases, and I'll show you the videos for them right now. So here they are. This one is the one with 1000 frames, so the longer one. Now this computer is pretty slow, so it kind of if you just saw that, it kind of screws up the video play. But let me scroll back to the beginning. You can even see watch how the water is gonna flow in. See, the water flows in. Now it's heating up. Water is continuing to flow, continuing to heat up, getting yellow, orange, and then I believe red is next. Darker orange actually, and then red. Okay. And this looks much more smooth if I wasn't using a ghost drive. It would come out more smoothly. So basically at the end of this video, we're coming pretty close to what was our final results for the steady state analysis. Okay, and I've got sorry, I wanted to close that. Got another one. This is to compare that to this one here. This is only right here. So the previous one only went up to 308 because that was the case where I had done 600 time steps. This is the case with 1,000 time steps. So it takes more time steps. It's longer and it goes up to a higher temperature. And this is right about there. Yeah, this, if you remember from the other tutorial, looks a lot like our steady state results for the temperature contours. Okay. Alright, well, basically I hope you enjoyed this. I'm gonna end here. Just a couple of quick comments I'd like to make is that you can use these tools to make a lot of different animations with transient cases. I hope this helps somebody. The only thing I would like to note is that if you're trying to do a animation that is concerned with the flow of the water in this pipe, my main concern with this simulation was the heat transfer, or the change in the temperature contours with time, right? But if I were more concerned with the flow of the water in this pipe, when you start before you run your calculation in Fluent, you have to do something that's a little bit of a pain in the neck, but I'll probably go over that in another tutorial. If you're concerned with fluid flow and you want to see how the fluid is flowing in, I guess the fluid front, you have to first patch the volume with air if that's what it originally contains. You can also patch it with a different fluid, but let's say it's a pipe with air in it, and then you want to open up a valve and have water flowing through the pipe. You have to patch the pipe with air before you run your calculation, and that's a whole separate tutorial. There's some other guys on YouTube that have done a pretty very good job doing that. I'll probably try to do one in the future, but that's just something to note. I'm concerned with the temperature contours here, so I didn't patch the fluid volume. Okay, and there you go. I'm pretty excited because I'm pretty happy with these results. They look a lot like the results from our steady state analysis. Okay, well, thanks for watching, and hope that you watched one of my other videos. I'm going to be posting a combustion tutorial probably by the end of this week, if not the beginning of next week. Alright, thanks. So long.